Let's take a look at ES 2015, better known as ES6. This is New School JavaScript. What is ES 2015? Also known as ES6, this is the 6th version of JavaScript, which was released in 2015. It's called ES because ECMAScript is the technical term for the language that we always refer to as JavaScript. So this version corrected a lot of behavior in JavaScript that had caused developers a ton of headaches. And it wasn't until this version of the language that a lot of developers considered the language mature. And people could argue about that, but regardless of their opinions, JavaScript isn't going anywhere. It is the language of the internet used in web browsers and now also on the back end with Node.js for server-side scripting, and it is only gaining speed. Let's take a look at why this version of JavaScript really changed the game. First, variable declaration. There are now 3 keywords that you can use in JavaScript to declare a variable. 2 of those are new, aside from the var keyword, which you're already used to using. The reason that we needed these words is because in JavaScript, there was a problem with variables polluting the global scope. If you weren't careful, your variables could end up everywhere. So variables from all over the place, different files, different functions could end up in the global scope, and then it's very difficult to write clean, well-managed code with that problem. So these 2 new keywords give us block scoping. So variables created with these keywords don't inherently jump to the global scope and pollute everything. Let's explore. First, the var keyword. This is the standard variable declaration keyword that you're used to. We can declare numbers, strings, Boolean values, whatever we want. This simply creates a variable for us. You can still use this keyword, of course, but it is recommended that you take advantage of one of the 2 new keywords. The first of which is let. The let keyword has block scoping. So this allows us to declare variables that are not in the global scope, even when they're outside of a function. If we use the let keyword, we can keep them contained. Let's see how this affects our code. Here's a for loop with var, and it iterates over 5 buttons on a page, and it is supposed to log out the looped value assigned to it. That would be I right there. I have a page ready for us to test. Here are 5 buttons. Here's the code. Buttons 0, 1, 2, 3, and 4, simply named by their index. Notice there's no extra functionality here. All the functionality that we add to this page is going to be in this JavaScript file here, app.js, and it is going to be from this code. So let's copy this and see what happens. Saved it. All right. We are grabbing all the buttons on the page by getting all elements by tag name button. And for I equals 0, as long as I is less than buttons.length, we're going to add 1 to I and run this code. So buttons at I, that's going to be 0 through 4 in this case. We're going to add an event listener, specifically a click listener, so when the button is clicked, something's going to happen. There is our anonymous function, our set of instructions, so that when the button is clicked, these instructions will run and we will see an alert saying button I was clicked, whatever I is. So hopefully we'll see 0, 1, 2, 3, or 4. Again, these are saved. Let's go back to our HTML page and refresh. I'm going to click button 0, expecting to see button 0 was clicked. Button 5 was clicked. This is not what we expected and not what our code looked like it should do. Button 4 also says button 5 was clicked. Same with button 2. So something is wrong here. If we take a look at the code, I doesn't have a keyword in front of it. So when we only had var, there was no way to clearly lock I down into this for loop the way that we wanted. So this I is not I right now, right here, 0 through 4. This I is the one and only global variable I. And while we set it to 0 at first, we did increment it every time we ran our loop. So it eventually increased after we ran our loop the last time to 5. And that's when we checked and I was no longer less than the buttons.length and we left the loop. So we have one variable I, again that variable here, And since I is equal to 5, all these buttons are showing that button 5 was clicked. That's not what we want. Let's instead use let and see what happens. We have let buttons up here, but the real use of let comes down here when we say let I equals 0, and that means that I is this I right now, right here, inside this loop, not a single global I that's polluting everything. So let's copy that code over, save, and return to our page, refresh. When I click 0, button 0 was clicked. When I click 4, button 4 was clicked. This is what we wanted our code to do. Thanks to the let keyword, I is contained and it is exactly what we wanted it to be. So using the let keyword ensures that you are talking about this variable right here, right now. Const is another powerful new keyword, and this one gives us constant values in JavaScript. So this helps save us from having variables that shouldn't change accidentally change. So for example, if we were using the var keyword, we can declare a variable named name and set it to Donnie, and we can later reset its value, reassign its value with the equals sign, the assignment operator, to Alan. That's fine. Anything declared with a var can be changed. And the same goes with let. Let still allows us to change values. But with const, we now treat this name as a constant. Once you assign it once with an equals sign, you can't do that again. This will cause an error because it is a constant value. You can no longer change that value, use the equals sign again on the fly. That could be problematic. So if we can't change the value of a constant variable, how can we work with things like arrays and objects? Because we do want to change them. That's the whole point of using them. And here's the beauty of this new keyword. We can still mutate arrays and objects. We can still change their properties, call their methods. They can still change shape, but we're just not allowed to redeclare them. We're not allowed to say that this variable name is ever equal to something else again. Here we declare my array is an array, and we can not do that here. Again, we only get to set it equal to something once. But down here, when we declare our array, we can still use the array's methods like push, and that's going to change what's in the array, and that's totally fine. Objects work similarly. Once you declare an object, assign it a value with the equals sign, you cannot do that again. But it's still fine to set the object's properties, such as myObject.name, using the equals sign. So this object is still the same object, it just now has a name property equal to Donnie, and that's fine. But we've saved ourselves from accidentally referring to a different object or other value because we used the const keyword. Something else that es6 gives us are template literals. This is a new way to declare strings, and it has a lot more functionality than we did previously. You can now declare strings with the backtick character located to the left of the number 1 key on your keyboard in the top left corner. The first advantage of backticks over quotes is that we can now have multi-line strings. Take a look at this. With quotes, we had to declare multi-line strings like this. We had to concatenate them. We have a lot of opening and closing of a new string, so a lot of quotation marks and a lot of plus signs, all to add these values together in a way that I can still read as the programmer. Also, if I wanted to add spacing in here or line breaks, I would have to take care of that separately. I would have to add \n to add a line break if I wanted that to be part of my string. With a template literal, it's a lot easier. Backtick, anything goes, line break, spacing, anything, and then our closing backtick. So all of this is that string. We can basically write HTML directly into our JavaScript. Very convenient. I can now take an element on my page and set its inner HTML to my new element, and this HTML will be inside it. Interpolation is another super useful advantage to multi-line strings. So again, let's see the old way of doing things. We had a variable, name equal to Donnie, and we can console log, hey, my name is plus name, how goes it? Let's take a look at this in our console. All right, so we could add a space there, but you get the idea. that works. But we can make things simpler with interpolation. So now we have backticks around our string, and this value, $, and everything between the curly braces, is interpreted directly. So whatever the value of name is, that's going to appear here. When I run this, we see, hey, my name is Donnie, how goes it? Notice we have our space. It's a lot easier to read what the final output of template interpolation is going to look like than it is plain concatenation with all the plus signs and closing and opening quotation marks. This is a lot cleaner and, as we can see, a lot more effective. ES6 gives us new functionality in terms of functions as well. So in JavaScript, we have two ways to declare a function. Function declaration, just outright, and function expression, which is setting a variable equal to the function. Declaration looks like this. We use the function keyword, we give it a name, and then the body of the function. An expression is where we declare a variable. This could be let or const as well. Var, whatever we want to name it, equals, and then our function. Now, in addition to this, we have something called arrow functions. All right, let's refactor an old style function, traditional function that didn't take any arguments, and we will make this an arrow function. So we have function log to the console. I'm going to set my constant log to the console equal to, and this is the syntax for an arrow function. Instead of having function with possibly the function's name in there before our parentheses, we have nothing. These are anonymous. So this is simply a raw function. And I'm going to assign that function to our constant value log to the console. So this is now going to be this function. It takes no arguments, and with no arguments, it logs print me to the console. Press enter, no errors, that worked. Now if I call my function log to the console, I get print me to the console. So that's how we can use a function expression with an arrow function. Let's see what it looks like to have one argument. So here's our original function number squared, and this is going to take a number and it's going to return that number times itself. Let's again declare this as a const. And we don't use the function keyword with arrow functions, and we don't give them a name, but we can assign them to this variable here. No error. Let's try number squared. We'll pass it 3. We're expecting, oops, not 30, 3. We'll expect 9, and we get 9. So this is a way of declaring functions without having to use the function keyword. It is shorter and in some cases more effective. Here's an example of using arrow functions with multiple arguments. And you can keep adding as many arguments as you want in here. So this is called add two numbers. Let's declare that as a const. We're going to set it equal to a function that takes two parameters, two arguments, and with those, it returns their sum. It adds them together. Press enter, no errors. I'm going to call this add two numbers. Everyone knows that 1 plus 2 is 3. Now, you can make this even shorter because these curly braces that we put around our function body aren't necessary. So, if we remove them, since we're only doing one thing here, we can remove the curly braces and the return statement. And we have, with no arguments, just plain parentheses, console log print me to the console. So now if we call log to the console, this will happen. We can shorten number squared even more. We don't need these parentheses around our arguments we can just give them a name, and we don't need the curly braces around our result, our return value. We can just type it straight out. So this is our entire function. It takes in x and returns x times x. Let's test that. Const number squared, I'm going to name it number squared 2, since I already declared number squared, and that will give me an error if I try to redeclare it. No error, that worked. Number squared, let's give it 5. 5 squared is 25. And the same goes for adding two numbers. For our final arrow function that took 2 arguments. Notice that if there are no arguments, you need empty parentheses to show that this is where our arguments would go. If there's just one, you can just put it there. But once you get to more than one, you do need to add the parentheses again so that you can see where your argument list starts and stops. So let's test this out. Add two numbers, 2 again because I can't redeclare it that const. And when I execute this with 5 and 6, we expect 11. So these are a lot shorter than the old original way of declaring functions. You can practice using the new functionality available to you in es6. To do that, pull your original JavaScript challenge exercise here and answer the same questions using es6 syntax. This is a repository with a JavaScript folder and an app.js file. And each of these comments, each line here is a challenge that you should be able to do. Make the H1 in the header have different text, for example. Do this using es6 syntax. Further resources include this list of es6 features. You can go through them on the left. There are a decent number of them, definitely more than we were able to cover in this video. And this article on making your code cleaner, shorter, and easier to read. Just a succinct list of tips and tricks for how to take advantage of es6.